Today we'll be talking about geometric series. Geometric series is a sequence or series where the term to its predecessor is always in which the ratio of any term to its predecessor is always the same number. The ratio is called common ratio. So the definition is a bit complicated, but it's a really easy concept. So consider 1, 3, 9, 27, 81, ... This is in geometric series because you see that it's being multiplied by the same terms, like times 3, times 3, times 3, times 3. So the ratio between 3 and 1, 27 and 9, 81 and 27 will give you the same ratio, that'd be 3. So R, that is the common ratio, which is given by the ratio between the term's predecessor and the term itself. That'd be 3 divided by 1, so 9 divided by 3, which is equal to 27 divided by 9. 27 and so on. Basic, it's really simple. So the standard way of representing it, A times first term A, then the second term A r to the power minus 1, A r to the power 1, sorry, A r to the power 2, and ... How do you find nth term of this? So it is A r to the power of n minus 1. Why n minus 1? Because we can see the power of r in each of the cases to be lesser than the position that the term is in. So you see that this is the second term of the A, so the first, second, and the power is 1, which is lesser than the position of this term. Sorry, it's second, right? This one's the third, and when it's the third, it's lesser than the power. It's greater than the power. It's greater than the power of the term by 1. So I think we should solve a sum now. Basic sum 2, 6, 8. These are in 2, 6 and 2, 18. 2, 6, 18. So can you tell me, because this is the first, second, and third, tell me the fourth term. What is the fourth term? Alright. We know that the common ratio would be 6 divided by 2 is equal to 18 divided by 6. 3 is equal to 3. This is the common ratio. What we do is, first term, using this formula, 2 times r, which is 3, n to the power of n minus 1, which is the fourth term, so minus 1 would give me 3. 2 times 3 to the power of 3 is 27. 54. So we see that the answer is 54. Fourth term would be 54. Try it times. We could have done it using a simpler method. Times it by 3. 2, 54. Next term would be 54. Moving on to some of the arithmetic series. Some of the geometric series. Sum of geometric series, S, denoting the sum, geometric series, to from the power n. So A plus a to the power of 1 plus a to the power of 2 dot 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 plus a to the power of n minus 1. Now, do the same thing, but write it the other way around. So a to the power n minus 1 plus a to the power r plus a to the power, a to the power 2 n minus 3 dot 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 plus a to the power, yeah. Now, thinking about this, we can multiply this whole thing by r. So you get r as n is equal to a r to the power of n plus r to the power of n plus 1 plus dot 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 a to the power of r. Yes. A times r to the power of 1. Sorry. Yeah. So what we can do is we can subtract this and this. Equation 1, equation 2, we can subtract. We could subtract these two. So when we do subtract them, we'll have Sn minus S sub n minus r times S sub n, which is equal to. So if you subtract them all, just remember that in this equation, you don't have a. You don't have a because remember you multiplied everything by r. So you don't have a, and yes, you don't have a to the power a times r to the power of n in this one. So what you do is when you cancel this, what will happen is that a remains here because this a, when you subtract these two equations, a is not here, so you can't subtract this from that. But remember that, and when you subtract this and this, you don't have a times r to the power of n over here. So what we can do is cancel out this, cancel out that, and then cancel out everything else. Cancel, whatever. Cancel. Have a minus a to the power of a times r to the power of n. Well, I'll say it again. I'll try to explain it to you guys again. I'm not really good at explaining stuff, but